Hey everyone, Tanner Pappenfuss here to share with you my final project for 1.125, Architecting and Engineering Software Systems. Hope you enjoy! For my final project, I look to unpack the traditional ETL data engineering workflow and show how tools like dbt can help us as we move to the future of data engineering. Traditional ETL has been around since the 70s. On the left, we see this traditional ETL workflow. On the right, we see the ELT model. Unsurprisingly, the key difference is where the transformation occurs. In the traditional ETL, these transformations are done on SQL servers, user local machines, virtual machines, etc. On ELT, you standardize these transformations and run them on top of the data in your data warehouse. One of the tools used to accomplish this is dbt. dbt offers a couple benefits to its users. First, a seamless integration with Git, meaning all your code is version controlled. You can easily share the models you create with other developers. dbt also offers an easy testing framework out of the box, which you can use to test all your push changes. This ensures you never push code that affects functionality downstream. Finally, dbt democratizes your data. Any user looking to build products can do so, whether that user is a data analyst using SQL or a data scientist using Python. All users can easily create datasets for reporting, data science activities, and operational workflows. In order to show how ELT and dbt can be utilized in a data engineering workflow, I use the Kaggle Spotify dataset. This dataset has 45 CSV files. Those CSV files are spread evenly between 15 genres, with each genre having 3 CSV files that you can see here: playlist data, playlist tracks data. You can see the database structure for the indie genre on the right. This structure is the same for all 15 of the genres. In order to get those CSV files into AWS, I built a Terraform pipeline. Terraform is an open source tool that enables you to create and change your infrastructure in AWS. So using YAML scripts and Terraform, I created and set up the 3 following AWS infrastructure components. First, an S3 bucket. S3 is the AWS blob storage. I created a subfolder for the CSV files and then loaded those CSV files from my machine into S3. Second, a glue instance. This creates a crawler that will put files from S3 and create tables for each of those files. It also creates a glue catalog that infers the schema of my CSV data in S3. Finally, I set up Athena. Amazon Athena is an interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL. Once I had created the infrastructure, I was able to trigger my glue crawler. The crawler pulls my CSV files from S3, infers the schema, and creates a table to store that information. Athena can then run on top of this to run queries on top of those tables. All right, let's run through a little demo of dbt and Athena. Here you can see the dbt homepage that is auto-generated documentation for my dbt project. Down here on the bottom right, I can click to find the lineage of each of the views that I have created within dbt. Opening up the Projects tab, I can open up a specific view and see more details, description, columns, what that view depends on, and the actual code itself. Opening up Athena, I could run a query against that specific view and visualize that here in the query window. Thank you so much, and I hope you enjoyed my presentation on data engineering.